This lesson covers some introductory material for Chapter 8. In particular, we're going to look at the distance formula. I'm going to show you where that comes from and how to use it. And in using it, we're going to look at what are called loci, the singular being locus. And the examples we'll do for a locus will turn into circles or lines. So first, let's look at where the distance formula comes from. Suppose you have 2 points that happen to be graphed and you know their coordinates. And I'm going to do this in general, so I'm just going to call the coordinates x1, y1, and the other point is x2, y2. And I want to know the distance between those 2 points. Well, what I'm going to do is draw in a right triangle and then use the Pythagorean theorem to find this distance, which I'll call d, between those 2 points. Now, in order to use the Pythagorean theorem, we need some expression for the length of each of the legs of this right triangle. So the horizontal leg goes from x1 to x2. That means its length would be x2 minus x1. Because if you think about it, if it's going, say, from 5 to 11, it's 6 units long. And we can make a similar argument for the length of the vertical leg being y2 minus y1. And now what I'm going to do is write the equation that would result from the Pythagorean theorem. The Pythagorean theorem says that you can get the hypotenuse squared by taking the sum of the legs squared. So x2 minus x1 squared plus y2 minus y1 squared. And what we really want is not the distance squared, but the distance. So we take the square root of each side. There's no need for a plus or minus when we take the square root of each side because we understand distance to be a positive amount. So we mean the positive square root, y2 minus y1 squared. And there you have it. That is the distance formula, which is written down here at the bottom in, I guess, maybe neater looking symbols. Note the subscripts, x2, y2, x1, y1. Those are not exponents. Those are there to distinguish the 2 different points that you're finding the distance between. Let's look at how to use the distance formula. Suppose you're asked to find the distance between 2 points. Well, you just plug into the distance formula. The distance is going to be the square root of, and then I have to subtract the x-coordinate. So negative 8 minus 3 and square that. And then to that I have to add the difference of the y-coordinates, negative 12 minus negative 5 squared. And then simplifying that, negative 8 minus 3 is negative 11 squared, and negative 12 minus negative 5 is negative 12 plus 5, which is negative 7. And then that has to be squared. So I get the square root of 121 plus 49, or the square root of, let's see, 9 and 1 is 10, 5, 6, 7, the square root of 170, which I don't think is going to simplify because that's 17 times 10, or yeah, that won't simplify. So that's how you use the distance formula. Now I'm going to talk about what a locus is. A locus is a description of a set of points. So the locus you see here says, or the problem you see here says, sketch the locus of points that are r units from the point HK. Well, you should remember enough from geometry to know that if you have some point HK and you take a bunch of other points that are exactly the same distance away from it, in this case r, you're going to get a circle with a radius r. And now what I'm going to do is use the distance formula to describe this locus of points. So any point on the circle, I'm going to call it xy, and I'm going to write an equation. Well, I know that the distance between xy and hk has to be r. So the distance between xy and hk, well, it's going to be x minus h squared plus y minus k squared, and that is going to be the specified radius. So I'm applying the distance formula. So x minus h, that's the difference of the x coordinates, and y minus k. And then typically the way we write this equation, we square both sides, and we get x minus h squared plus y minus k squared, clean that up a little, equals r squared. And this is the equation for a circle centered at hk with radius r. Here's a specific example. Suppose I ask you to write the equation for a circle with a center of, say, -5, 3, and a radius of, say, 4. Well, I write it like this. It's x minus -5, or x plus 5 squared, and then y minus 3 squared, and that should equal r squared, which in this case would be 16. So that's how you write the equation of a circle, and it comes from the definition of a circle and the distance formula. Okay, in this next example, you're asked to sketch the locus of points that are equidistant from 2 points. So I'm going to start by just locating -1, 1, 2, 3, 4, and 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Well, the most obvious point that's equidistant would be the midpoint, which I guess is about right there. But from geometry, you might remember that the perpendicular bisector, and my picture's not perfectly accurate, but the perpendicular bisector of the segment connecting the 2 points are the points that are equal distance from the 2 points. So now I'm going to show you how to describe that locus with an equation. So what I'm going to do is just call any point that is part of the locus xy, and I'm going to again use the distance formula. Well, the distance formula should tell me that the distance between xy and each of these other 2 points, that those distances are equal. So the distance from xy to -1, 4 would be the square root of x plus 1 squared plus y minus 4 squared, and that should be equal to the distance from xy to 2, 8, which is x minus 2 squared plus y minus 8 squared. Again, I'm using the distance formula between xy and each of these 2 points. So the first thing I'm going to do is square both sides of the equation to get rid of the square root. So x plus 1 squared plus y minus 4 squared, and then the square root's gone on this side as well. And as you're looking at this, you may think, wow, I'm supposed to be getting a line. This doesn't look anything like the equation of a line. But watch what happens when I now expand each binomial. X plus 1 squared is x squared plus 2x plus 1, and then I get plus y squared minus 8y plus 16. And then on the other side of the equation, I get x squared minus 4x plus 4, sorry, it's getting crowded here, plus y squared minus 16y plus 64. And now, notice there's certain things that are on both sides of the equation. So I'm going to think about subtracting x squared from both sides of the equation, and what that's going to do, it's going to drop out of both sides, and I'm going to do the same with the y squared. And now you see why this is going to turn out to be linear. So now I'm just going to gather all my variable terms on the left-hand side. So there's a 2x, and I'd have to add 4x to both sides to get that to move over, so I'd have 6x. That takes care of the x's. and then I've got a negative 8y, and I'm going to have to add 16y to both sides, so that's going to give me plus 8y. And then on this side, my constants add up to 68. That's 4 and 64. And then I'm going to have to take this 1 and 16, or 17, and subtract it, which would give me 51. So here you have the equation of the line, which is the locus of points equidistant from -1, 4, and 2, 8. For your homework, I want you to do the two problems you see here on paper, and as shown in the video, you are to find an equation to describe each locus. I do want you to submit your equations online before coming to class, and that way I know if people understood how to do it. But please also bring your work on paper to class. That will be collected. Also, understand when I say sketch the locus. I use the word sketch when I'm not expecting your graph to be 100% accurate. I just want to see that you understand the idea.